Assalamu alaikum students. We will continue with chapter 1 material properties, and today's topic is discovery and organizing of elements. Last week we studied what are elements and how to write chemical symbol for each element. Yes, so let us quickly revise what we studied in the last session. Chemicals are pure substances that have only one type of atom. Each element has its own different type of atom. Examples: hydrogen, carbon, iron, gold, oxygen, calcium, zinc, copper, etc. And there are many more examples. Total, there are 118 elements in the periodic table, out of which 94 are discovered naturally. They occur naturally on the earth, on the planet. Now, how to write the chemical symbol? If there is one alphabet, the alphabet will be capital. For example, carbon, C will be capital, and if there are two letters, Ca for calcium, first letter will be capital and the second letter will be in lowercase, capital C and small a. Now let's continue with today's topic. Can you all see this is a periodic table of the elements? Dmitri Mendeleev was a scientist and philosopher who arranged all the elements in the periodic table in the year 1869. Before going to the arrangement of the elements in the periodic table, let us see some of the older history of the elements, how they were discovered and who discovered them. Now, early ideas about the elements. What is early idea? Let us see. For thousands of years, thinkers thought about elements. They wanted to know more about simple substances that make up everything else. So, more than 2000 years ago, a Greek thinker, Aristotle, you all must have heard about him. A Greek thinker, Aristotle, created an explanation. He said there were 4 elements: air, water, fire, and earth. This idea was popular for hundreds of years. So he said that there are 4 elements: air, water, fire, and earth. And this idea was even accepted by the people. Scientists in India used the explanation to help develop their ideas about atoms. From about 1700 years ago, scientists realized that the idea of 4 elements was wrong. They looked for substances that did not break into simpler substances. They already knew about some of them. So, what do you think? Was the idea about 4 elements actually wrong? Yes? Let's see. So, this is the picture of Aristotle and 4 elements that these are the 4 elements about that he explained about, that what everything is made up of on the earth. First is water, fire, air, and earth. Earth means nothing but trees, soil, organisms. Let's continue. The first discoveries: sulfur, gold, copper, and coal. These were some of the first discoveries by the scientists. These elements were discovered first by the scientists. Let us see how. Some elements exist naturally on their own. Early humans saw sulfur near volcanoes. Sulfur was found near volcanoes. They made charcoal by burning wood. They found gold in stream beds. So, well, where was sulfur found? Sulfur was found near volcanoes. Charcoal was made by burning wood, and gold was found in the bed of rivers. Stream beds. Stream beds means in the bed of rivers. Now, how was copper found? Copper also existed on its own. That means copper is a natural element, but most copper is found joined to another element in the rocks. It is found naturally, but it is joined to another element in the rock. People started extracting copper from its rock 7,000 years ago. They used copper to make weapons, tools, and jewelry. So copper was used to make different artifacts like weapons, tools, and jewelry. Later, people mixed copper with tin to make bronze. So, is bronze a natural element? No. Bronze was made artificially when copper was mixed with tin. The properties of bronze means that it makes excellent swords and knives. People first extracted iron from rock about 3,500 years ago. They made tools and weapons from iron. So these are the first few discoveries of the element: sulfur, gold, copper, coal, iron. Bronze was made artificially. Then let's continue. In the years 1200 until 1700, zinc and phosphorus was discovered. Let us see how zinc and phosphorus was discovered. It was not easy to get zinc from its rock. Zinc was also attached to the rock. Zinc was found naturally, but it was attached to the rock. So they started heating zinc at high temperature. When zinc was heated at high temperatures, zinc evaporated easily. Zinc evaporates easily at high temperature. So the scientists started heating zinc at high temperature, and the zinc evaporated easily and escaped into the air. Then Indian scientists solved this problem 800 years ago. They heated zinc containing rock. Zinc containing rock means the rock to which zinc was attached with waste wool enclosed container. Now when zinc was heated with waste wool enclosed container, the evaporated zinc did not escape into the air. It was trapped in the container. And so that evaporated zinc was collected and made solid again. Then phosphorus. Scientist named Henning Brandt made the first phosphorus artificially. He evaporated water from urine. From urine, water was evaporated. Urine was heated to such an extent that all the water present in it was evaporated. He heated the solid that remained until it was red hot, as you all can see in the picture, red color. That's phosphorus. So how phosphorus was made? Water from the urine was evaporated, and the solid that was left behind was heated until it was red hot. Then in 1700s, elements from the air and more metals were discovered. Scientists, metals like nickel, magnesium, oxygen, and nitrogen. Scientists discovered 17 new elements in 1700s. They isolated nickel from, that means they obtained nickel from rocks and magnesium from pond water. They separated oxygen and nitrogen from the air. Henry Scientists named Henry Cavendish and Joseph Priestley removed oxygen from the air. Then, when they removed oxygen from the air to test whether the experiment was correct, whether the oxygen was removed from the air, they had put a mouse in the container of remaining air. What do you think would have happened to that mouse? Because oxygen was already removed. The mouse died. There was air, but still the mouse died. Why? Because oxygen was removed from that air. Another scientist named Daniel Rutherford explained the evidence. He said that air is mainly nitrogen. So when oxygen was removed from the air, what remained in the air, what was left in the air? Nitrogen. This is the reason the mouse died. Then in 1800s, different technologies was introduced. The discovery, there was 1800 in 1800s, more than 50 elements were discovered. More than 50 elements of the periodic table was discovered. A new piece of equipment called as spectroscope. You can see the first image, golden color instrument, that is called as spectroscope. This spectroscope helped the scientists to discover two new elements, cesium and rubidium. You can see in the picture below how cesium and rubidium looks like. So in 1800s, more than 50 elements were discovered, out of which spectroscope was used to discover these two elements, cesium and rubidium. Aluminium was also discovered in 1800. It wasn't found earlier because it is strongly joined to oxygen in the rocks. So even aluminium was discovered in 1800s. Aluminium is strongly joined to the rocks, and so it was not discovered earlier, that because it was not easy to obtain aluminium. Then 20th and 21st century, most of the elements were discovered. The last gaps of the periodic table were filled in 1920s. The last the gaps that were left in the periodic table. Scientists made more than 25 artificial elements in the 20th century. Russian and American scientists created element 117 in the early 2000s, and this is how the periodic table was complete. This is the picture of periodic table, and this shows different colors represent the year in which the element was discovered. So the purple color, all the elements which are in purple color were discovered before 1200. All the elements that are in orange color were discovered between 1200 to 1700. All the elements that are in blue color were discovered in the 1700s. Then the elements which are in yellow were discovered in the 1800s, and the elements that are in green were discovered in the 1900s. Now, after discovering the few elements, organizing the element was very important. So, scientists in the year 1860 had found about 60 elements. They became curious about organizing the elements. So they started asking different questions. What are the patterns in the properties of elements? They started finding patterns in the properties of elements. How many more elements are there? Can we use patterns and properties to help find new elements? So these were the questions that arose because scientists became more curious for organizing the elements. These questions are empirical questions. Scientists could not do experiments and make observations to help answer them. But scientific evidence alone would not be enough to answer the questions. Creative thinking was needed. Scientists hoped to develop an explanation to answer the question. They wanted to use the explanation to make predictions too. So the scientists they started working on organizing the elements. They started thinking creatively. They started searching for explanations and evidences. Now comes the arrangement of the modern periodic table. Dmitry Ivanovich Mendeleev, born in 1834 and he died in 1907. So, let's see who was he. He was born in Siberia, the youngest of 17 children. He had 16 other siblings. He was refused admission to the university, became a school teacher, and loved to play patience, a card game like solitaire. So this is a brief description about Mendeleev. You all can see the picture also. Let us see and learn about his work. The periodic table. For many years, scientists did experiments and made observations to collect evidence about properties of elements. Then, Mendeleev he began to group elements that had similar chemical and physical properties. He started comparing the properties of chemical and physical properties of elements, then grouped according to the atomic mass and bonding power. Saw patterns and he saw patterns amongst the element. So this is how he started doing his work. First, he studied the proper chemical and physical properties of the elements. Then he grouped them according to its atomic mass and bonding power. Saw patterns, and then he saw patterns. He recognized patterns amongst the elements. Then he knew that some elements have similar chemical and physical properties and thought that these similar properties were the secrets to a hidden pattern. To discover this pattern, Mendeleev wrote down each element's melting point, density, atomic mass on and color on individual cards. When arranging the cards in various ways, Mendeleev noticed that a pattern of properties appeared when he arranged the elements in order of increasing atomic mass. The atomic mass, he noticed a pattern that when he arranged the elements, he noticed that the atomic mass was increasing. As he moved forward, atomic mass was increasing. Group by group, this arrangement became known as the first periodic table. Elements in the periodic table are arranged according to their atomic mass, based on their atomic mass. So Mendeleev was the first person to arrange all the elements in the periodic table. So the periodic table is called as the Mendeleev's periodic table. The periodic table is named as Mendeleev. Then, after arranging, there were few gaps left in the periodic table. "63 known elements, there were 3 blank spaces." After arranging 63 known elements, there were 3 blank spaces. These spaces were elements that had not been discovered, and he has even able to predict these unknown elements based on their chemical and physical properties. Then scientists had to fill the gaps that were left in the periodic table. So other scientists tested the explanation. They tried to find the elements that Mendeleev had predicted. In 1874, a French scientist found one of the missing elements. He discovered the element under aluminium and called it gallium. The properties of gallium were those predicted by Mendeleev. Wow, isn't it amazing? Swedish and German scientists soon discovered 2 more of Mendeleev's missing elements, scandium and germanium. The evidence showed that Mendeleev's predictions were correct. Scientists were confident in his great explanation. This periodic table is the foundation. The periodic table that was arranged by Mendeleev is the foundation of modern chemistry. Now, how they worked on finding the missing elements, you all can see the image below. They went with the flow. They asked a question, suggested an explanation. They tested the explanation, and then they checked for the evidences. So this is how modern periodic table was organized and finally complete.